Hey guys, I hope everyone's doing well in these strange times. So my name is Abramov. I've been at Beeswax for 4 years, and for the past 2 years, I've been on the professional services team, basically helping Beeswax clients build custom optimization solutions and implement them on top of Beeswax. And today's topic is why build a custom algorithm. And so for the agenda, we'll define what a custom algorithm exactly is. We'll take a look at the performance landscape and see why this question is even relevant to begin with. We'll see how available off-the-shelf algorithm solutions don't necessarily solve the problems that the modern performance landscape poses. We'll review how the custom algorithm solutions actually help you solve some of these problems. And finally, we'll see how to implement custom algorithms on top of Beeswax. So without further ado, what exactly is a custom algorithm? So a custom algorithm is a multivariate mathematical model that uses historical impression and conversion data to predict the likelihood of future impressions leading to specific outcomes. So to slightly unpack it, effectively, you have a bunch of historical performance data. You want to make sense of it. So you apply a statistical learning technique that recognizes patterns in characteristics of impressions that either lead to conversions or don't lead. And then you apply these learnings to incoming traffic to improve your buying logic and improve campaign conversion rates. And so why exactly is it relevant to even address this question currently? So for a number of reasons, all related to the challenges and the characteristics of what performance campaigns entail today. So to begin with, single level attribution models no longer really work, right? All modern campaigns are like I tailored towards down the funnel engagement and positive return on ad spend, and that requires a multi-event and multi-touch attribution model. Secondly, we have more data now than we've ever had, right? Traditional performance data sets can be overlaid with multiple first and third-party data points that can better inform your buying decisions and better predict what types of traffic lead to desirable outcomes. Thirdly, virtually, like it seems every month there's some sort of rapid advancement in machine learning or analytics tools that are currently available to clients. So not only do you have increasingly sophisticated data processing services such as Snowflake, for instance, that really simplify the process of storing, organizing, querying vast amounts of log level data. You also have a number of open source statistical learning solutions that are remarkably effective at accurately classifying events and sort of like categorize them appropriately, whether an impression leads to a conversion or not in digital advertising space. And finally, there's a demand for transparency, right? We no longer exist in a world where a positive performance outcome is the only thing needed to satisfy a client. We need to be able to explain exactly how we drove that outcome, what changed, what didn't change, and what we plan to do in the future to continue improving on build progress. And so that's all fine and good, but why not use off-the-shelf solutions in order to address these problems and take into account all of these factors? Well, part of the problem is because the traditional DSP platform has been built in a one-fits-all solution type of way, where really when the vendor is not trying to optimize for solving custom problems, they're trying to create a solution that works for as many different clients in parallel as possible, which creates its own problems. And what are those exactly? So first of all, the majority of off-the-shelf algorithms optimize against a single event, which, given the fact that the funnels nowadays are fairly complex, poses a problem, right? Because, okay, if we try to optimize towards a final purchase event, let's say, typically you don't have enough conversion signal to optimize towards it accurately for a very long period of time, which forces you to start optimizing towards up the funnel events, right? Which, okay, you might get a more accurate prediction score, but often, let's say a landing page visit doesn't really lead to like a purchase, right? Or the desired outcome. So it kind of creates this chicken and egg issue where, okay, you try and optimize towards something that's relatively relevant, but you're not exactly sure how that translates into ROAS. So, it's not exactly ideal. Secondly, most traditional DSPs employ legacy attribution techniques, right? So it's either last view, last click, past 7 days, past 30 days. Again, as we mentioned, majority of clients nowadays are not necessarily interested in using such attribution methods, right? They want it to be more sophisticated. They're often working with external vendors such as Visual IQ, who are providing insight into what represents a true conversion versus what's not, and seldom can you actually implement that insight seamlessly into your campaign on a traditional DSP. Thirdly, these algorithms are trained using aggregated and often limited training data. So what does that mean? Well, first of all, it's often impossible to effectively utilize all campaign data, right? Seldom do you have a campaign that's completely fresh, right? Usually you will have some relevant insights that you can potentially imply in order not to start from scratch. And I haven't seen many platforms where you can take these learnings and inform the algorithm of these learnings in order for it to account for all campaign data, right? You can somehow manage it by, let's say, establishing bid modifiers, implementing targeting lists, but one, that's not really apples to apples, and two, it creates a decent amount of ad ops overhead, right? So then with training data, right, the training data is not campaign specific more often than not. It's pulled from multiple advertisers and campaigns, which effectively means that you're not really optimizing for the conversion that you want to optimize for. You're optimizing for some diluted version of an end conversion, which sometimes works, but more often than not, it doesn't really drive the same conversion rate that you would expect. And last but not least, the same set of features is used across the board, whatever campaign you're using, right? So what do I mean by that? So let's say the DSP has decided that the 5 features that they want to optimize for when they deploy these algorithms is domain, placement site, app, day of week, right? Those are going to be the 5 features that are universally applied to all of the campaigns that you run on top of the DSP, regardless of the fact that there might be other features, right, that carry a lot of predictive signal that are being completely ignored and therefore having a negative impact on how accurate your algorithm is designating impressions as converting or not converting. And then on the reporting side, there's a lack of transparency on training and validation methods. Like when we talk about custom algorithms and deploy them in-house in Beeswax, we're always looking at various accuracy and performance metrics. We're running back tests on various slices of data to understand, okay, is there like seasonal fluctuations that we need to account for? How well does this algorithm work against like the older versions that we've deployed? Whereabouts with traditional DSPs, none of this data is available. You really have no idea what to expect, right? You just need to pray and hope it works, and, you know, ideally have a team of traders aggressively slicing and dicing traffic to guide the off-the-shelf algo in the right direction. And so now that we've reviewed the sort of like the major issues that you encounter with off-the-shelf solutions, let's talk about how custom algorithms can help you solve some of them. So on the optimization front, first and foremost, the first thing that at least we do internally at Beeswax is we focus on understanding what is the best feature set for a specific campaign and campaign goal, right? There's often a lot of overlap, right, between similar campaigns. Like for instance, right, if you're running a web campaign, you know that domain, site ID, publisher ID, placement ID will have like a strong amount of predictive signals. So you always have to account for them. But in many cases, you'd be surprised to see what features are impactful versus what not. And analyzing all of the available features, segmenting them differently is an important step in defining your training data before you try and generate a custom algorithm. Secondly, you can try various different statistical learning methods, right? Whether they're open source frameworks such as, and I'm sure you've heard a lot of these, you know, you've got powerful gradient boosting algorithms such as XGB Boost, Cat Boost. You've got the more sophisticated frameworks such as TensorFlow or Keras, right? Or it's you know, internal proprietary statistical learning method. You can try all of them in parallel, train different models, use the same sort of like performance benchmarks to see which one works best, and then use that one to train the final custom algorithm. And last but not least, you can create ensemble models, right, to drive multi-event optimization. So as you know, right, throughout the life cycle of a performance campaign, right, hopefully you accumulate more and more conversion signals for low the funnel events, right, as you optimize the campaign and spend more money, right? So you don't need to have a model that optimizes for a single step within the funnel, right? You can combine multiple models, each of which focuses on a separate step within the funnel, and combine the scores outputted by these different models together in order to produce a true expected conversion rate that can, you know, that will influence your bid CPM decision, and therefore your conversion rates much better. On the attribution side, right, given that if you're building a custom algorithm, you're storing your own historical performance data, and that gives you a lot of flexibility in terms of how you slice and dice that data and what you add to it, right? So from an attribution standpoint, one, you can set, custom attribution look back windows. You can designate different weights for different types of events. So you can really sort of like play around with how you designate a conversion before you attribute it to an impression. And furthermore, as I mentioned, right, if you're working with an external vendor like Visual IQ, given the fact that those vendors will typically have access to cookie IDs, user IDs, IP addresses, auction IDs, right, data anchors that enable you to merge different data sets together, you can incorporate their insight in order to better inform how you attribute your conversions. On the data front, as I mentioned before, you can overlay your performance data with a variety of first and third party segments, right? And whilst, different campaign will react differently to the introduction of behavioral contextual signals, more often than not, you will definitely find some segment data that will improve your algorithm accuracy by, let's say, 5 to 10%, which in the course of, a multi-month campaign with significant budget, it leads to significant savings and obviously much better outcomes with the client. And you can also incorporate all campaign data. No longer do you have to start from scratch, right? If you ran this campaign recently and the data is still relatively fresh, you can just use it to build the first version of your custom algorithm, plug it in, and then, refresh the predictions based on like incoming fresh data, right? And then on the reporting analytics front, right, no longer is it a black box where you can't really explain what's going on, right? You can present your clients with the performance benchmarks attached to each of the feature sets that you've tested, each of the different learning algorithms that you've tested. You can compare all versions of your custom algos versus new ones. And ultimately, it just paints a much better story with the client as to what you're doing, what works, what doesn't work, and provides them with a lot more confidence. And then in terms of options available on Beeswax to implement custom algorithm solutions, there are two APIs that we've worked with. One is a bid model API and the other one is a bidding agent API. And so the difference between them is minimal, but it's important to outline. So multivariate models or bid models was an API that we built for clients that have data science resources, right? They understand how to house data, how to process it, how to analyze it, how to deploy statistical learning methods on top of them to create custom algorithms, but they don't necessarily have the engineering resources to, place that custom algorithm in a server somewhere in AWS, plug it in and monitor it for latency and whatnot. So in this case, what you can do is you can take the custom algorithm that you developed, you can generate a ton of predictions against your win, bid, auction logs, basically any logs that represent the flow of traffic to your bidder. And then, that's in CSV format and just upload them into S3 and Beeswax will pick it up and view that as effectively, your custom algo. It'll represent the opinions that your model has on different types of traffic that are available to your bidder. Now, if you have a bigger team with, enough engineering resources and you can maintain a server where you deploy the algorithm, right? We have a bidding agent API where you can do exactly that, right? Instead of scoring different auctions in batch, right, and uploading to S3, you can simply upload your model object onto a server, right, plug it into Beeswax, and Beeswax will route traffic in real time to your server endpoint where your algorithm will score it, convert the prediction rate into a bid price, and submit it back to the exchange. But the one thing that I would like to outline is that both of these APIs, while the implementation is different, they're effectively leveraging true custom machine learning or custom statistical intelligence. It's just manifests itself in slightly different forms, but certainly are both very powerful. And yeah, that's pretty much it on my end. So I'll leave the floor open to Q&A.
Yeah, thank you, Alex. So we do have a few questions. Let's start with this one. How long does it take to build a model for an advertiser, and what are the typical resources needed? We do get this question a lot, so this is a good one to answer.
That's a great question. So let me put it this way. So if you're starting from scratch, right, and you're building a model for the first time, it'll probably take you a couple of hours to perform the necessary analysis to determine what training data set you should use, right? So as I mentioned, for instance, feature analysis is going to take probably a little bit of time, given that, there's 40, 50 relevant features available in the OpenRTB request that you can take a look at. But once you've figured out, okay, these are sort of like the parameters that I want to focus on for this campaign, on average, I think it takes us anywhere between 30 to 45 minutes to train a model. So it's really quite fast. And in order to do this, really, some of the clients that we've been working on recently, they simply have, let's say, a single data engineer, a data scientist. We have an open source code base that we share with them, that we walk them through, and basically teach them how to replicate our internal pipeline efforts on their end to generate these models from scratch. The code base is pretty refined at this point, to a point where it's, it involves maybe 5, 6 different steps that are easily configurable, right? So it's pretty easy to use. And yeah, overall enables people to spin up models in, let's say, half an hour to 45 minutes on average.
All right, thank you. Next question, how do you define the objective function of your algorithm? By parts of the funnel having n algorithms, or do you mix it as one?
So we kind of do a bit of both, right? It depends on how much conversion volume is available. So in cases where you don't and so to kind of take a step back, for us, what we found is you need to have at least 100 conversions within the last 30 days in order for the model to be able to, predict outcomes with reasonable accuracy, right? So let's say 80% of the time will be accurate. And in some cases, we can generate those 100 final conversions very quickly, in which case we'll just do single event optimization. And in cases where those final conversions take a bit longer to accumulate, right? What we'll do is we'll train multiple models in parallel, where each model will output conversion rate attached to its specific event. And then we'll combine them together to create effectively a final conversion rate that will then dictate what price we should submit.
All right, thank you. Next question. What is the value proposition of Beeswax custom algo versus commercial DSPs like DV360 or Xander that also offer the option of uploading our own custom algo? Thanks.
Cool. So to my understanding, there's a couple of limitations. So for one, most of the custom algo APIs that I worked with, one, they don't necessarily support like a full set of features, right? So there's maybe 10, 15 features that you can work with, which often can lead to decreased model accuracy. Two, the format in which it supports it is often fairly inflexible. So for instance, with the AppNexus Bonsai, right, you effectively need to use their own language in order to build a model, whereabouts with Beeswax, let's say if you're using a bidding agent, you can deploy the code in any language you want, right? As long as it satisfies the latency requirements, you're good to go. And yeah, I would say those are probably the two biggest difference makers. One, Beeswax effectively supports unlimited feature set, right? Meaning that it maximizes the opportunity for your model to be as accurate as possible. And you can deploy these custom algorithms using various software programming frameworks, depending on what you prefer. Yeah.
And Alex, is it also true that there's the notion of being able to get out all of your log data to validate some of these, so some of the performance metrics that you just can't get with something like DV360 or Xander that takes a random sample of auction data?
Yeah, absolutely. So first of all, on the win and conversion data, right, there's often significant limitations to what information is included in them. And with Beeswax, we basically, we provide you with everything that's available to us, right? So for instance, one of the biggest differences that I've seen is often segment ID data is not included, which